What is going on, guys? So in this video what we are going to do is to write a function that counts the number of nodes in a given linked list. This function should basically just receive a list, okay? It should receive a list, then it should count how many nodes are there in that list, and finally it should return this count. Pretty simple, right? Nothing complicated. Just receive a list, okay, get a list, count how many nodes there are in this particular list, and return this count to whoever called this function. And the first thing to note here is that, as opposed to static arrays, for example, we cannot know in advance what is the size of a linked list. We simply usually have a pointer to the head of the list, and that's it. We don't have the exact number of nodes that a current list has, because we said that we will mostly use lists as our preferred data structure for tasks where there are frequent changes, and when we have frequent changes we cannot know the size of the linked list. And also, one question that I've been asked a lot is actually goes like this: why do we have to write a function? Can't we just use size of? So that's one of the questions I've been asked. So why do we have to write a dedicated function for that, something like that, a dedicated function for that? Can't we just use size of, okay, the size of operator, and it will tell us the exact size of the linked list? So actually we know that with linked list we work with pointers. We have our head pointer pointing to the head of the list. For example, we know we have a list with a couple of nodes, and we want to find out how many nodes are there in that list. We simply can't just use the size of, because what should we put in the parentheses of this size of? Should we put just the head? If we do so, something like that, so size of head, the head pointer, we will simply get the size of a single pointer head, and obviously not the size of the whole list. Not even the size of the node itself, it will be just the size of the pointer. So I think that's a good idea why size of won't work here, the size of operator. But if you still think something can be done with that, please try it out and let me know. That's an important part of the studying process. Okay, so let's move on and write our simple function. Okay, so there you go. So first of all, what we created here is the template structure for the node in our linked list. And what we will do is just to write a function. Okay, so we know that the function returns what it returns. It returns a count, right? A count is simply an integer, so the signature is going to be of an integer type, and then we will specify the function name. So for example, count nodes in list. Okay, and what should the function receive? The function should receive some address, that in this address we have the first node in this list. So what we can do here is simply to use node star, okay, because we receive the address of the first element, and we have here node star head. Okay, for example, we're receiving the address of the first node in this list. And now what we want to do is to write the function body. So for that we will create int count. Okay, we will set it to be 0, and this will be the count of the nodes in the list. So count will represent the count of the nodes. And also, just for simplicity, but it's not mandatory, let's create some additional pointer, let's call it temp. Okay, and we will set temp to point to head. Okay, so we will still, although it doesn't really matter in this function, we will still keep the head of the list pointing to the head of the list, and temp will simply iterate and run over each and any of the elements in this linked list. So Now what we have to do is to write a simple loop that will iterate over all the elements, and as long as we haven't reached the last element, we will use count plus plus. Okay, so while, and here will be some condition, as long as this condition is true, then count plus plus, and we will use temp equals to temp next. Okay, so every time we will take the temp pointer and point to the next element in this linked list. Okay, so the main question that should be asked here is basically what should be the condition in this while loop. So if we want to say what will be the condition in just our words, we will say that the condition would be as long as we haven't reached the end of the list. Okay, so as long as this is okay, we will run the body of this loop. So while, and how we will treat this part like haven't reached the end of the list. So we know that every node has a data and it has a next pointer. And one thing that we know about lists is that the last element in the list should point, this next field should point to null. That's what specifies that the list ends in this given node, because in the standard ways, that's how we find the length of the list, okay, and that's how we find the end of the list. So simply, as long as we can say that temp next, as long as the next temp does not equal to null, okay, so if a given node that temp points to, if it has a next field, and this next field points to null, meaning we don't have any further nodes, meaning we are at the end of the list. And that's why we should finish up with this condition. The result of the condition should be false, and we should be out of this loop. And once we are out of this loop, we have been iterated, we have iterated over all the elements of this linked list, count all of them, and we simply will return the number that we have found, so return count. So int count, count is of type int, the type, the signature, everything seems to be okay. So there you go, guys. This is our function to count the number of nodes in a list. So count number of nodes in a list. Awesome.